Next slide. So welcome everyone. My name is Alan Rossiter. I'm at UH Energy at the University of Houston, and I'd like to welcome you to our webinar this afternoon, Turning Energy Savings into Cash Savings. This event is hosted by the Texas Industrial Energy Efficiency Program and co-hosted by the Lone Star chapter of the Association of Energy Engineers. And we appreciate funding from the State Energy Conservation Office. The speakers today, our four speakers, represent the Texas Industrial Energy Efficiency Network, which is not quite the same thing as the Texas Industrial Energy Efficiency Program, but it is very closely related. TIEEN, or the Texas Industrial Energy Efficiency Network, is a network of publicly supported energy efficiency organizations. And so the four speakers represent four of those organizations. And taking them in order for today's presentations, we have Gavin Dillingham, Director of the USDOE Southcentral CHP-TAP. And he'll be speaking about the benefits of CHP and WHP in industrial facilities. And after all that alphabet soup, I assure you he will explain what all that means during his talk. Second speaker will be Kurt Middelkoop, Senior Sustainability Engineer, University of Texas at Arlington, with the TMAC program. And he will be talking to the subject of leading lean to energy savings. And number three is Jim Eggebrecht, Assistant Director of the Texas A&M Industrial Assessment Center. And he'll be talking about how to reduce your operating energy costs in a hurry. Now, our first three speakers will all be looking at things from a more technical standpoint. Our final speaker, Dub Taylor, will be looking at the money side of this, or the financing side of this. Dub is the Chief Operating Officer for the Texas PACE Authority, and he'll be talking to the subject PACE, a new financing option for industrial energy, water, and environmental projects. Next slide, please, Lee. Now, we have a very full program today, and in order to manage things more efficiently, first off, I would ask you, please, if you're not one of the speakers, please stay muted and keep your video off. And also, I will not be giving lengthy introductions to any of the speakers, but you can get the speaker bios and other webinar details from the link that is on the screen there. And you should also find that that information is in the chat box as well. Maybe you can put it in there again, Kyle, because people who came late may not have got it. But basically, if you want to read up about the speakers, the information is there, and also more information about this webinar. I know quite a lot of people who come to these webinars are interested in getting certificates of participation so they can claim professional development hours. And again, that is available. We have an automated link for doing that. Again, the link is given on the screen, and it will also be in the chat. And when you click on that link, it'll take you to a window or a web page for the certificates. However, the submission period is not yet open. So if you go there now and click on the button, nothing will happen, provided it's not been broken. At the appropriate time, we will activate the link, and at that point, you will be able to claim your PDHs. And then one final note, the Q&A, we're going to try to keep this very simple today. You can enter your Q&A simply into the chat box, and after each of the talks, we will take a little bit of time to see what questions are there and try to answer as many of them as we can. And so I think with that, let's move on to our first speaker, who is Gavin Dillingham, and he will explain to you a bit about the USDOE Southcentral CHP-TAP and the benefits of CHP and WHP at industrial facilities. Over to you, Gavin.
Great. Thank you, Alan. Appreciate the opportunity to come and speak with everybody today. Yes, so we're going to be covering CHP, WHP, which is combined heat and power and waste heat to power there. And I think it's really important that we start looking at this, especially what we saw in February, as well as some of the other outages we've started to experience more, the importance of on-site power generation that's both efficient, resilient, as well as it reduces emissions here. So next slide, please. Just quickly, the Department of Energy's Combined Heat and Power Technical Assistance Partnerships, those are 10 different regions around the country focused on end user engagement, stakeholder engagement, and technical services. And so some of the more important work we do is really helping end users better understand what their opportunities are for CHP. If that's a microgrid, maybe you're bringing in solar plus storage with a CHP system, maybe it's a standalone CHP system, but really run that early stage technical assistance and see how they can move that project forward. Next slide. Next slide there. We're going to do a CHP overview for those that are new to it. So CHP, once again, is really this on-site generation system. You bring in a fuel, typically in the United States, it's natural gas, runs an engine and turbine, turns that generator, and then provides electricity to that site. In some cases, that power is exported back to the grid, but in most cases, it stays on site. The efficiencies and the benefit of the CHP system is really capturing that waste heat, whether that's steam or hot water, and using it for a variety of potentially industrial or manufacturing processes or domestic hot water, and in some cases cooling, such as using it through an absorption chiller there. Next slide. The other type of CHP that we're looking at, the first one was top cycling. This one's also known as bottom cycling or waste heat to power. So essentially you're grabbing waste heat off of an existing process, whether that's maybe a compressor station in a pipeline, or you have a natural gas processing plant that's generating a lot of heat. You capture that waste heat and generate power by capturing that waste heat via a heat recovery steam boiler. And then you can also, in some cases, while you're generating electricity, also use some of that excess heat for potentially other processes there. But really, the growing interest and benefit of waste heat to power is the emissions benefit that it provides, as far as it does not create any additional emissions to create and produce electricity. Next slide. There's a wide range of CHP opportunities or applications that are available and technologies that are available. As you see here, we can go from very small systems to say 5 kW up to larger systems up to 300 megawatts. And we're seeing them really around the 1 to 3 megawatt as far as a lot of the stuff that we see recently, as far as kind of what we've been doing technical assistance on. But the important thing to keep in mind here is that it's a wide variety of applications, and in many cases, applications that we historically have not seen for CHP. And I'll go more into that here in a second. Next slide. So some of the key benefits of CHP that we just need to keep in mind is really, the efficiency that's brought to that by having both that generation and capturing that heat and using that heat for a variety of beneficial purposes. You have a more efficient system. You have lower operating costs. Significantly, you have reduced emissions, and that's becoming a growing concern as far as how do we reduce CO2 emissions as well as overall improve air quality. And what we're seeing also a growing interest on is really how they can improve the resilience of the grid, as well as reduce power grid congestion. Utilities are growing more and more interested as far as how they can strategically place CHP systems, as well as distributed energy and distributed energy to see how they can reduce congestion, how they may not have to go out and do maybe a large transmission distribution build, but instead look at more strategic placement of these distributed energy resources. Next slide. Where we are today with CHP, it's pretty significant amount of power generation in the United States, about 13% of industrial generation, 80.7 gigawatts. You see a variety of different applications there. Typically the traditional places with chemicals, refining, pulp and paper, and manufacturing and food processing. But as I said earlier, due to the flexibility of CHP, we're seeing it in more in hotels, in the hospitality sector, K through 12. We're seeing it more in commercial office space, especially as they look to use it for absorption chilling and such. Next slide. So what are some of the areas where we see growing opportunities? And this is based on a 2016 study that the Department of Energy did looking at technical potential. The blue is existing CHP capacity, and the green there is the technical potential. Once again, the chemicals, still not surprising, that's still a very important place for CHP. But once again, the commercial buildings, colleges, universities, district energy systems, we're actually doing a program with the Department of Energy now looking at community energy and district energy systems. How do we promote that effort? But really across a wide variety of sectors, you see industrial, primary metals, refining and such. So still a significant amount of combined heat and power opportunities there. Next slide. And when you look at waste heat to power, you see a wide variety of opportunities there, still predominantly kind of in the manufacturing, refining space with petroleum refining, primary metals, kind of the stone, clay, glass sector there, and oil and gas extraction. And on the oil and gas side, we see a lot going in at compressor stations and kind of being driven in that regard. But overall, across the United States, about 8 gigawatts of technical potential available there. Next slide. I kind of alluded to this earlier, but the utilities are really getting a lot more interested in CHP systems. If those of you who have worked in this area in the past have seen, utilities have typically not been very friendly towards CHP because they see it as a way in which to reduce revenue potentially. But now we see utilities seen as an opportunity to use it as a non-wired alternative. So essentially going out, instead of going out and doing a rate case and building maybe new transmission distribution or new infrastructure there, they're looking at these distributed energy resources to really find ways to strategically place it to reduce congestion and provide ancillary services and benefit the overall grid. And so you see in some cases utilities are actually owners of these CHP systems. In other cases, they just work closely with the end user site that's hosting that and see how it can provide additional benefit. You're also seeing in some cases improved rates around CHP, more incentives around CHP, as well as waste heat to power. Not a significant number, but a growing number there. So once again, utilities are much more friendly to CHP than they have been in the past there. Next slide. One of the other areas where we're seeing a lot of interest is CHP and microgrids. So not CHP just standalone, but how does it start integrating a variety of other kind of production resources, generation resources. And CHP does a really nice job with integrating solar plus storage, especially if you're looking for a further emission reduction profile there. And so bringing together those different types of supply resources to kind of match the load there and optimize the load for that site is really being used quite a bit more with CHP. The Department of Energy actually came out with a new tool called REOPT, R-E-O-P-T, that focuses specifically on CHP and microgrid deployment using CHP plus solar and storage as the primary focus there. Next slide. Another key thing, once again, I pointed to earlier, is just the resilience benefit that CHP provides. And this is from the Resilience Accelerator Department of Energy did a few years ago, showing the different types of natural disaster and storm events that, potentially could impact a site or a facility there. And just to kind of demonstrate that when you look at the different types of criteria as far as fuel supply interruption, damage to equipment, forced shutdowns, performance limitations, CHP seems to operate pretty well in that regard, especially when flooding and high winds, which can be kind of important when you live along the Texas Gulf Coast or in just Texas in general. But overall, CHP operates fairly well and has been deemed very resilient across most cases here. And when we saw during Winter Storm Uri, majority of the systems that we talked to after Winter Storm Uri sailed right through. There was one site that had a bit of an issue just due to lack of winterization, but pretty much every other site did very well during Winter Storm Uri there. Next slide. Typically, when we start talking with folks about CHP and they start saying, well, what about backup generation? Why don't I just use a diesel generator? And it definitely has lower upfront costs. But when we talk about CHP, we want to talk about the full life cycle cost and long-term cost associated with that. And so just important to kind of point out the differences there as far as, for example, CHP system operates 24/7 versus a backup generator that, may operate once or twice a year while you're not testing it, and maybe or maybe not you're testing it. And so whether or not the system comes on is always a question. CHP is always operating 24/7. So it's running. You also know the natural gas infrastructure, for the most part, is highly reliable. There's definitely less natural gas outages than there have been as far as power outages, customer outages. Texas kind of tested that theory over February, but overall, and the overall development and operation of natural gas systems is typically highly more resilient than, say, the natural gas systems, and highly more resilient than, say, a diesel generator there. I wanted to go to the next slide, please. I wanted to quickly go into just waste heat to power. So you go to the next piece there and kind of drill into that a bit more. The key point here for waste heat to power is not only providing significant industrial efficiency by grabbing that waste heat, but really it's that emissions reduction or that you have there, that pollution-free power that you're grabbing there. And so when we're talking with a lot of folks about how do they improve their environmental social governance standing to some degree, if it's a large manufacturer or industrial site, waste heat to power can really do a nice job there generating emissions-free power and ensuring that they have resilient, reliable power on site. Next slide. And when we look at CHP, there's a variety of ways in which you can get access to CHP. If it's from a thermal process, so it can be recovered, say, from a furnace, an oven, a kiln, other industrial processes converted to electricity. The most common way is through a Rankine cycle there. Engines and turbines can be used to drive compressors, pumps, and electrical generators. An example of that would be like a pipeline compressor station to kind of generate electricity in that regard, and we're seeing a growing number of those. And then some industrial processes generate heat as a byproduct, such as when you're making fertilizers, incineration of sewage sludge, heat released from pressure relief valves, and other processes that produce heat. You can grab the waste heat off of that as well. So a lot of different ways in which waste heat to power can be grabbed there. Next slide. All right, going to just a couple project snapshots real quickly. Next slide. The first one is the waste heat to power site over in Port Arthur. This is a site that actually won an Energy Star Award back in 2010 due to the efficiencies that it brought, significant CO2 emission reductions, and not a large system, a 5 megawatt system at a petroleum refining plant, but really a good example of how you can reduce emissions and really provide that robust, resilient power at that site. The next one. What we have here is the Eggebrecht Industries site in Garyville, Louisiana. This is a combined heat and power, so a top cycling plant, similar size. It's using a gas turbine here, producing power with processed steam. And the focus here was largely reliability of both steam as well as electricity. And has demonstrated itself to be a pretty robust, resilient system and have been operating since 2012. Next slide. All right, so there's always these questions of, you've talked about all these exciting, wonderful things about CHP and waste heat to power. How can we work together in order to make sure that a project becomes a reality for you? If you go to the next slide, we can talk about that. For this particular case, as I mentioned, we do a lot of technical analysis on this, economic analysis. We run sensitivity analyses. We can really dig pretty deep into how the CHP system or a waste heat to power system can work at your site. There's a lot of ways in which we try to help engage through the whole project development process, whether that's first of all, just giving you that first step of see, is it economically feasible? What's the sizing of the system looks like? What's the thermal production? Does it work for absorption chillers or not? Is there a cooling application associated with it? And then we also do a lot of work where we just kind of look at, do third-party review of investment grade audits, or look at drawings and not approve drawings, but we can look at drawings and say, yeah, it looks like it's doing what it's supposed to be doing. Or, we help through, especially if you're a public entity or just doing a competitive bid process, go through the RFP, RFQ process, making sure that it's written up well and you're asking the right questions there as well. So really kind of help and almost become a project rep to some regard there to really help drive the CHP piece. And, once again, we're a free resource. We're a no-cost resource provided by the Department of Energy, so we don't charge anything for this. And we really just try to make sure that this process is smooth as possible for everybody. Other things we just kind of work on, once again, is we do a lot of outreach and education, a lot of workshops. We try to do tours as much as possible, but sometimes, or at least especially in this time of place in the world we are now, difficult to do tours and face-to-face, but we're just around really trying to promote the word and really talk about the efficiency benefits and the emission reduction benefits of CHP. Next slide. Just a variety of resources that are out there, a lot of different fact sheets to talk about the different types of different types of technologies, the cost associated with those technologies. There's a great database out there. There's all the CHP projects and gives you an idea of where they're deployed, how they're deployed. There's some great accelerators out there with the Resilience Accelerator that really helps kind of do some resilience screenings. We do a good number of resilience screenings for folks and really help them better understand, how do you prioritize your site? Say you have a portfolio of sites, how do you kind of prioritize investment in those, looking at their different types of resilience factors associated with that. We look quite a bit at policy trends, regulatory trends, making sure that those are better understood, and how potentially, such as the waste heat to power tax credit that was recently passed at the federal level, how that could potentially benefit and make the project work more cost effectively there. So once again, a resource on the policy side, the regulatory side, as well as program profiles, project profiles to show best practices, lessons learned, ways in which you can just get a better, more concrete idea of how it works. Next slide. So next steps, here we are as a no-cost resource for combined heat and power and waste heat to power, here to help you make sure you can work through your process. So happy to answer any questions and further have these discussions. So thank you very much for the opportunity today.
Great, thank you, Gavin. Thank you. quick, I have a couple of questions for you actually, and if anyone else has questions to add, please put them into the chat box and we'll deal with as many as we can. But the waste heat to power tax credit that you mentioned, that is something pretty new, right? When was that implemented, do you know?
It came into being just recently within the last few months or
Okay,
so. So it had always been kind of combined heat and power, and that one had been kind of staging down.
Mm-hmm.
But through the work of actually the CHP Association or CHP Alliance, they were able to get a new waste heat to power. And also the Heat is Power group did a nice job in getting that as well. I got to give them credit. So yeah, it's come out within the last few months, and we're excited to see how it can potentially drive waste heat to power applications, because as I mentioned, the emission savings reduction are key. The efficiency benefits are important, and I think, especially as we look at competitiveness of manufacturing and industry, the ability to grab waste heat in that regard and use it in an emission-free resource is important.
And while we're on the subject of waste heat to power, your service includes both CHP and waste heat to power. Where do you find the greatest interest has been? Which of those?
It really depends. So we cover 11 states. So it really depends on which state we're working in. In Texas, it's a nice combination of waste heat to power and CHP, so both top cycling, bottom cycling. When we also cover the Upper West region, which is more Rocky Mountain states up to the Dakotas and Montana. And in there, it's more combined heat and power, and it's typically smaller type sites, although we are doing more compressor stations and looking more at waste heat to power options at compressor stations where they're looking to either power the site, and in some cases, power the site and export power to generate some revenue in that regard. But it's really an interesting mix. And a lot of the projects we're doing now are, it's a wide, we do end up doing 60 or so of these a year, and they're pretty wide breadth of them, but we're seeing more coming in actually it's kind of funny in the hospitality sector, especially up in our Upper West, where they're trying to keep the pool operating 24/7, 365. And so use CHP for keeping the pool warm.
Fair enough. I did have one other question related to the waste heat to power. The organic Rankine cycle is something that all of my career, and I have to say that goes back quite a long time. People were always talking about organic Rankine cycles, and they've never seemed to be economic. Are you seeing applications now in some of your waste heat to power applications where they are able to use organic Rankine cycles cost effectively?
Yeah, we've seen actually a couple recently that have been for flare gas, and where they've used it in that regard, used an organic Rankine cycle system in that regard. But you're right, it is tough, it is more difficult to pencil those particular kind of projects out. And it's really kind of a case by case, and really where do you get the, what's that price of electricity? You look across our region, there's some parts of the state that, the cost of electricity from grid power is fairly low, and it's hard to make those projects pencil out. Other parts of the state, prices are a bit higher and the economics look better. But what we're seeing more people ask questions about is, how do you assess that resilience benefit with that? Okay, so if I look at upfront costs and I'm paying X% more for my electricity, but what's my business disruption cost look like? And what does that look like if I go down, and as the likelihood of me going down seems to be increasing over time, how do I start factoring that into my decision making? And so we have a lot of conversations around that, as far as how do you start factoring the resilience benefit? And so it's kind of shifting discussion from just what's that simple payback to overall what's the resilience benefit that I may see.
Just one more quick question before we move on. There's a question here in the chat from Curtin asking about geothermal applications of organic Rankine cycles. Do you have any experience with that, or any comments on that as opposed to the waste heat to power?
We haven't done a lot of work, or we don't do any work in that regard. So I don't have anything I can comment on that particular one. Although I think geothermal is a wonderful technology. I think there's some great applications. Our building up at HARC, where I'm housed, we have a geothermal heat pump system, and we're now a LEED Platinum net zero building. It's pretty cool how you can apply it in different energy applications or HVAC applications.
Excellent, Gavin. Thanks so much. You had a great deal of information there, but you were able to get through it very effectively, and thanks for your answers. That's good stuff. So without lingering too long, let's move on to our next presentation, and this is from Kurt Middelkoop, and he'll be talking about leading lean to energy savings.
Thanks, Alan. So I am part of a national program called MEP, Manufacturing Extension Partnership. The funding has come out of NIST. The program started about 25 years ago, and most states have their own MEP provider. If you're not from Texas and you want to know who your MEP provider is, just look up www.mep.org to find out who your provider is for your state. So here in Texas, we are, TMAC is the MEP for the state of Texas, and a part of that activity is typically helping manufacturers to do anything that they can do to stay globally competitive. So over the 25 years, we have a variety of practitioners all across the state who work in different technical areas to help organizations to remain competitive. One activity that we have there, you can see at the bottom, it says E3, Economy, Energy, and Environment. UTA is the host organization for the MEP for Texas. We have also got grants from the Region 6 EPA to help do assessments that include a combination of lean, energy, and environmental assessment to kind of integrate those together. Okay, next. So this is the single slide. If I want you to remember one thing from my talk today is this. What I have learned in my years with TMAC is, as I work with practitioners in manufacturing or city governments or organizations, is that typically I'm seeing people who are very siloed in their thinking. So I would work with a lean person, or I work with an energy person, or I'd work with a safety person, or a financial person. And my message today is, if you are one of these cogs, what I want you to remember is no matter what cog you're in, they all impact the other. So if you are a energy person and you're trying to get the attention of the people in your organization, obviously you know there are financial savings from energy. And so that integration is key. In our assessments that we've done, we've done 112 assessments, and we found out that when we do lean assessments, 65% of our savings come from lean identification of lean waste. And from that, an additional 35% are the safety, environmental, and energy. So if you are not doing lean as part of your scope, you may be leaving some opportunities that could also help you in your agenda, whether it's energy or environmental or safety. Okay, next slide. So here's a practical tool that I use to kind of like, well, how do you do that, Kurt? So typically when we watch an organization's process, we will either video it or watch it, and we'll break down the actual steps of that process. We'll list the steps here. You can see where it says process step individually. We put times for those. Obviously, when something occurs, lean teaches people that you're either doing something that's adding value for the customer, or it's something that you want to try to reduce or simplify. So lean is about asking, why are we doing this? Where should we do it? When, how, who, all those. And with the goal ultimately to either eliminate, simplify, combine, or rearrange. So when we do those steps, we also are asking, in addition to the lean opportunity, is there an energy opportunity here? Is there an environmental opportunity? Is there a safety? What's the financial? So we're trying to link these elements together. That way you have a holistic approach to looking at your process to improve them. And the other message I'm going to say to you is this. Sometimes we look at a process and we think we see everything. Until you break it down step by step, you will never, your brain cannot fathom all the things that are occurring during that time. So I encourage you to use this tool, and I certainly can provide you the Excel format if you're interested. Next slide. Lean, if you're new to it, is simply about identifying things that you want to avoid. And I'm not going to talk to you a lot about lean, but I want to give you a quick snapshot. The things you want to avoid in your organization is, if you're making defective products, don't do that. If you're producing more than you need for your customers, what you can sell that day, don't do that. If people are waiting for things, waiting for parts, waiting for equipment to come up, don't do that. if you have people or processes or equipment that are not adding value to the activity. So for example, a motor running idling isn't accomplishing anything. So we're looking for non-value added activity. Transportation. Anytime you move things from point A to point B, back and forth, any type of movement, we're trying to reduce that. Inventory. Lean's about reducing the amount of WIP that's in a facility. In general, the least amount of WIP speeds up your process. The more stuff you have in your facility, the longer it takes. So we're very interested in looking at inventory. And then the last lean waste is motion. We want to look at a person working and ask, what are they actually doing to transform that thing into the product that the customer wants? Or a machine that you've got. If you look at it every split second, what is the machine doing? Is it idling? Is it getting ready to? We want to make sure that we're spending as much time actually converting the raw material into the finished product. So that's kind of an overview of lean. Next slide. So when you do lean, typically when you find a lean waste, it almost always has an impact where you find energy wastes that are there. So in our scenario, I'm going to show you an example. These are the lean waste or the energy waste that we use from the Department of Energy. These are the top areas: industrial, compressed air, motors, cooling, air conditioning, heating systems, and just turning things off. So these are the areas that we try to connect our lean waste and asking, well, how does it impact these that are energy waste? Next slide. So here's my example of an actual lean waste that was observed. What you're looking at is, this is a changeover at a bakery where at the end of the chocolate cake being made, they had to take all off, clean the entire system. And so you're seeing this gentleman on the left with a hose, and he is individually washing off every single part and laying it on the cart. So what it appeared to a lean person is, we have downtime. Why is this washing process taking so long? It took 20 minutes to clean these parts and another 30 minutes to put it all back together. So we had like an hour changeover. How could we shorten the changeover to get the machine back up making cakes again? Because when it's making cakes, that's when they're making money. So the next slide. So from that lean waste of waiting, what we realized that the solution, one of the solutions, was simply, how could we clean faster? So the answer to that was a nozzle, a $5 spray nozzle that could clean the parts faster. Obviously, it uses less water, and that led to a faster turnaround. So there was less downtime for that piece of equipment. Well, when you have less downtime, you can run the equipment and you can actually make the cakes that you need to during the week, and you don't have to bring people in on Saturday to do overtime to make the cakes that you needed, which then means you don't turn on the power for the extra 4-hour, half a day to power the whole facility. So a simple thing of water and waiting ended up being a big opportunity for energy reduction. So the linkage is, you see how it's there. Next slide. In addition to the energy, obviously all that water, if you follow it, it went down the drain and it went over to their wastewater treatment area, where obviously you see pumps and motors and filters and more pumps to treat that water. So this lean waste, we found a way to use less water because we're using a sprayer, so it reduced it significantly. And then we didn't have to run, the cost to run the water treatment was less for this opportunity. So you see how everything's integrated. Actually, if you'll back up, there you go, that's good, the slide there. One more slide, next, thank you. So the message is, if you're not integrating what your technical expertise is, I don't know who you are on the phone or on the call, but just think about your silo. Are you in a silo right now in your thinking? How have you engaged the other people in the other silos to be a part of what you're doing? If you're not doing that, there is a lot left on the table. So that's my preaching to you is, if you're in a silo, get out of that silo. It is uncomfortable. You may not want to do it, but in the end, in 10 years from now, whatever practitioner you are, you're going to be way better at what you're doing. So here's a couple other examples. Here's an example of a pickle conveyor, removing pickles from a vat. Simple problem. Well, the pickles were falling on the floor. So it was a mechanical defect that ended up, they used lots of water and lots of energy to make more pickles. So you can kind of see how a defect of a system led to more waste. Next one. Obviously, lighting, nothing new here. Obviously, I just want to state, as you all know, when possible, use natural daylight. So natural daylighting is the best. And when you don't, efficient technology. This company had the 1,000-watt energy, 1,000-watt metal halides, and they are replacing them with the 300-watt LED. So that, these are things that are there. But in addition to the lighting, think about the other things that are being impacted. Now we have the quality of the planes that are below there being inspected. They're going to probably find their defects. So in this example, better lighting helps you find defects sooner so your customer doesn't have you come back and repair those. So there's an integration here. Next slide. These are the motors that are at my bakery area. Again, during the clean out, a changeover, these motors were idling on a washer that wasn't running. So we simply said, hey, when you're doing your changeovers, you don't need to have these motors running full speed. Obviously, an integrated thing. It all started with the water spray that also led to these motors being turned off a couple hours a day. Next slide. And again, here's my photo. I like it because it's timeless. This was 10 years ago. These are old lights, but look at the lighting that's there. Don't forget to use natural daylight. And in this example, as you know, how does that integrate into efficiency or labor? Studies say that if you have natural daylight, your people are more productive. When they're more productive, you make more parts. So don't forget to integrate across those silo areas as you do your energy projects to bring all those players together. Next slide. So lastly, here's my contact information, but I did want to do an opportunity of something that you may be interested in. About 2 months ago, TMAC received a $1.3 million grant from the federal government to help any organization that's impacted in any way from COVID. So we are currently helping organizations with projects that are, the financial amount is around $10,000 to $20,000 at no cost to implement any of the things that I've just described. So if you're interested in signing up for a CARES grant, it's pretty simple. If you go to our website at www.tmac.org, or you can contact me, there's an application and it's very easy to get started. And the delivery of that grant is between now and the end of August. So it's free TMAC labor to assist you with a project if you've got something you're trying to work on and you're thinking, well, we don't have the funds, I would encourage you to reach out because we have this grant, which you may find very helpful. That being said, Alan, thanks for having me. Here's my contact and feel free to contact me. And again, thanks for attending the session, and I hope this information was helpful.
Thanks, Kurt. I also wanted to mention that if you go to the TEEP website and actually specifically the one that deals, the page that deals with this webinar, you will find, along with the bio details that are there for the speakers, there's also contact information. So if you miss what's on the screen now, you can also look there, and that was one of the links that we gave you earlier. In fact, if you have a chance, Carl, perhaps you can put that back in the chat box. But anyway, carrying on, questions. So I did have a couple of things to ask you here. You mentioned one of your opportunities that you presented, I think at the bakery, related to the motors they were running, was to turn them on and off depending on demand. So I've come across a number of situations like that where there's been pushback from maintenance people saying, well, that's going to increase the maintenance costs on the motors. Have you encountered that, Kurt?
Certainly, I'm an energy person, but energy people tell me, oh, well, you don't want to start and stop a big motor, right?
Right. Mm-hmm.
However, in addition to these motor, what we had was there was water usage that was happening. There was also detergent usage. So the this whole wash system was running as if the conveyor running the empty pans were going through it.
Mm-hmm.
So, yeah, I certainly hear maintenance people who say things like, oh yeah, well, you know, it's, you know, it may not ever get started back again. So I certainly would challenge them by, at a minimum, my job is to say, well, do you realize that we're spending $7,000 a year to whatever the number is to idle? I present the data and I let them make the call on that, right? I just want them to be aware of the opportunity. I certainly could give my opinion about what I would do if it was my place. I certainly at my home, when I need to turn off something, I turn it off, right? I don't leave things idling in my house. Maybe if I have an old fan that won't restart, I'll leave it going, but it's, you know, minimum. So I don't know if I answer your question, other than my role is to give them the data so they can then make a decision about, okay, do we want to do this or not?
Right, right, indeed. Understood. It's actually similar to another question here, and that is this. Again, in the baker, I think you were talking about the time they were taking for that cleanup. And because of, you know, being more efficient, they didn't need to do so much overtime once you've improved it. So the question also, in a sense, is similar to my previous one, or to the previous discussion here. Have you seen pushback from people on the plant when you're trying to make things more efficient? Because it basically takes work away from them.
Yeah, absolutely. One of the biggest things I've done with Lean is you literally will go into an area with 20 people, and at the end of the Lean event, you'll look at 10 of them and say, you don't need to be here. We don't need you here anymore. But what we do, TMAC has always told or asked companies, when we find an improvement, if you lay off people, you're never going to get any more improvement because people are never going to participate in an activity. So we encourage, so what I tell them is, if the company is more efficient and their pricing becomes better, the company ultimately could grow and bring in new business. So we try to get customers to commit to hang on to those people and allow the company to grow. Or when natural people leave on their own, just don't rehire them, right? When it happens, don't rehire them, but do not do the mass layoff because of a Lean event. And certainly the number of people that I work with that they're smarter than I am, they know, oh, I'm not going to get overtime. And I explain to them, if they have overtime all the time, you may not be here in one more year because there's another company that's doing the same thing without the overtime. So you certainly have to discuss that.
Yeah, so certainly there are human issues with all of these things, aren't there? And you're right. I mean, if you can turn these things into a productivity plus and an ability to get more throughput in your plant and make more money, then obviously it's a whole different situation than just saying we need to cut this job. You keep the job and you just make more product. If you can get that sort of situation, that's a win-win. I guess I do have one more question for you, and it is this. Are all of your jobs in food facilities? Because if so, I've been in the wrong business all my life.
No. My range of work in 25 years has ranged from studying the Dallas Cowboys football stadium, killing chickens, Texas Instruments clean rooms. Name any industry, metal and finishing, automotive, aerospace, farming. I've worked for a landscape company, a big nursery. So all industries, anyone that makes anything, I don't think it matters what it is, typically not agricultural, but I want to say that we have done some things like I worked at a facility that cured hams. So I guess I have, right?
Okay.
Yeah.
And did you get a cake at that bakery before you left?
Actually, if you didn't know this, if you go to Walmart or Tom Thumb and think, oh, wow, they're baking those cakes there, they're not. They're frozen. They're frozen at this facility, shipped flash frozen to the Walmart where they thaw them and then they decorate them. So no, I did not.
You did not? Okay. Had to ask. All right. Thanks so much. That was excellent. Really enjoyed that. Good stuff.
Yeah.
All right, so we're now over to Jim Eggebrecht with the Texas A&M IAC. And Jim, over to you.
Okay, Good afternoon, folks. My name is Jim Eggebrecht. For the last 27 years, I've worked as the Assistant Director at the Industrial Assessment Center at Texas A&M. As you can see on the list there, I'll be talking about some of our common recommendations and also highlighting some things on sales tax, power factor, and compressed air problems that we see. Those are some of the things that happened in a lot of the recent visits we'll cover also. You have my contact information there, and I guess the slides will be available. Please go to the next slide. The Industrial Assessment Center program is a program of the U.S. Department of Energy to assist small to medium-sized manufacturing plants with energy conservation studies. We go into factories with a small team of engineering students who are hired staff of the program for typically a one-day site visit to find ways and quantify the results of energy conservation efforts the plant can implement to reduce costs. The studies are done at no cost to the manufacturers. Now, this is a national program of the DOE, and there are 31 such centers scattered across the country. We are one of two in Texas, with the other one being at UT Rio Grande Valley in Edinburgh, Texas. We recently completed over 820 assessments and do about 25 of them each year. I personally have been on 475 of these assessments, and the students, by the time they graduate with the program, have typically done somewhere between 8 and 15 assessments themselves. Now, the criteria that the DOE uses for setting the small to medium-sized criteria includes that at the plant site, there have to be less than 500 people working there. They have to have no in-house on-site energy manager type person that could do the study. The gross annual sales of the plant site is less than $100 million a year. And the utility bills for primarily the electricity and natural gas we use mostly in Texas needs to be within the range of about $100,000 per year up to $2.5 million per year. Now, recently, the DOE has added a focus on water and wastewater treatment plants to our client list. But typically, we go to manufacturing plants. We have done some wastewater treatment plants in the recent year. Some of the common recommendations with, say, motors that we deal with, we'll look at putting in new efficient motors for an older motor that gets burned up. We also look at preventative maintenance issues. We're using a vibrometer or other analysis methods on the lubricants and the bearings and that type stuff to find ways to reduce the downtime and reduce the upsets that motor failures cause. We also look at recommendations to use synthetic lubricants in the motor bearings because the friction loss on these things is reduced by about 10% using synthetics over petroleum-based. We also look at cogged and notched belts for belt-driven systems. For some of the lighting things we deal with is figuring out the savings on lighting switches, going now from the fluorescent and metal halide to LED type fixtures. We also look at turning off lights during the daytime when daylighting can be used, which gets back to one of Kurt's points also. Also use occupancy and light level sensors to kind of mechanically do that also. I'll talk more about compressed air issues, so I'll kind of skip over that for right now. For boilers and cool systems, we often find things with boiler tune-ups, repair of the steam traps, repair of steam leaks, insulation issues that needs to be fixed, that type thing on the assessments. Power factor correction, I'll be talking about that in just a little bit too. So I'll kind of put off the discussion on that momentarily. Some of the productivity things we look at are things that would not save energy or waste, but would somehow save dollars. And one of the things along that line is the sales tax abatement. We'll talk about that here momentarily. Now these are the common things that we find that are simple for the plants to implement. And they're usually unique things, ways that we can walk into a plant and find ideas too. If you would turn the slide, please. When we first look at a plant's utility bills, we get copies of electric and natural gas bills for the plant for a 12-month period. And prior to the visit, we look at those to try and understand how the billing is done, see what rate tariff they may be under, look at the prices and all that type stuff. And one of the key things we're looking at is, are they paying sales tax on their utility bills? And I'll go through that just momentarily. We also look and see if they're paying late fees and or having power factor problems. We'll talk more about that later. But if they are paying sales tax, we'll tell them what the rules are about that in Texas anyway. In brief, in Texas, the rules are if the manufacturing energy usage on a meter, on a bill, is 50% or more used for direct manufacturing, then the plant can declare that that meter is tax exempt and stop paying sales tax on it. The study that officially determines this is performed by a professional engineer. It's called a predominant use study. Once the study certifies that a meter is tax exempt, then the PE prepares a certificate that is given to the plant or given by the plant to the utility supplier, electricity or natural gas. And then the supplier will stop collecting sales tax from that point forward. An added benefit, at least in Texas, is that the company can then go and apply to get back up to 4 years into the past of the past paid taxes rebated back to them. It's a little bit of a kicker. Now, there are actually 28 US states with this sales tax abatement, the same or similar to Texas. If you're from any one of the states listed there, or you have a factory that is likewise listed in one of those states, you might want to take a look at the electricity and natural gas bills and see if they're paying sales taxes, and see if it may not be necessary to do so. Now, the exempt uses for manufacturing include the direct plant manufacturing equipment, like the boilers, the air compressors, the motors, the press brakes, and things that actually go into making the parts and pieces of what are made. But it also includes the lights and the heating and cooling, the personnel comfort in that manufacturing area. That can be factored into the equation also. Not exempt uses would include the office area equipment, things in warehouses and maintenance, for instance, things that are not directly tied to manufacturing. Now, one thing to keep keenly aware of is that every time you change your utility supplier, particularly in Texas, if you change your electricity supplier from one month to the next, give the new supplier company that certificate all over again, or otherwise they'll have to start collecting sales tax, and you'll have to go through the process all over again. And we've seen sales taxes lead to some rather major savings. And you got to remember that the sales tax in Texas is 8.25% if you're talking the city, county, and the state version of it. So it's nice to be able to knock 8.25% of your utility purchase off your bills by pretty simple diligence on this issue. Earlier this spring at the IAC, we encountered a plant in the northeast part of the state that was paying sales tax to the tune of $205,000 per year for 7 electric and 1 natural gas meter. And the 4-year rebate on that came to a little bit over $820,000. So it's rather sizable, the savings. In addition, in the fall of 2019, there were 2 plants visited by 2 IAC teams on the same day. One of those teams found the sales tax amounted to $161,000 per year. And the 3.5-year rebate on that totaled up to $565,000. The other plant visit found $168,000 per year, and that had been paying sales tax for the year prior to the visit when they changed suppliers 12 months prior. So both of these plants failed to give a certificate to the the new supplier, so they start paying sales tax, and no one noticed it for a while. Sometimes, quite some distance in time. If you'll turn the slide, we'll talk about power factor correction here. Okay. Now, power factor affects your bill demand and costs. You pay for your electricity to your retail electric provider but you pay to the TDSP, your transportation delivery service provider, like Encore in, say, Dallas area, Houston to CenterPoint Energy. You pay them for the demand cost. And they have values for the power factor, the minimum values that you have to meet, or they will increase your bill demand over and above the actual demand. And the formula they use is that third bullet point there. It says bill demand, actual demand, power factor ratio. And the example there was taken from a plant up in somewhere in the north part area where Encore operates. They had an actual demand of 1,080 kW, power factor 0.82. If you go through the calculation through there, it says that the bill demand is going to be 1,251 kW. That's about 171 kW more than what the actual was at 1,080. With the demand cost running somewhere around $8 per kW in most places in Texas now, then that plant was paying about $1,400 more that month for demand. And if you take that on an annual basis, it's a little bit over $16,000 a year. Now, we've had some recent IAC visits where the power factor savings at one plant total $127,000 a year on a very large demand level, like 6,000 kW, and a demand of about 0.75, something like that. And typically, these implementation includes installing capacitors to correct the power factor. That's usually done at a point downstream of the electric meter and upstream of everything else in the plant. And the payback generally runs now, with the demand cost being up, somewhere between 1 to 2 years, often 1 to 1.5 years is fairly common now for power factor correction. So the economics on this are very strong. There was a recent article I wrote for Allen's Chemical Processing magazine thing, and that goes into more detail on power factor and how the sizing on the power capacitor banks are and all that type of stuff. And I'll excuse me, refer that to you for use if you need some more information. If you would go ahead and turn over to the next slide on compressed air. This is my last one here. And I would like to highlight 3 things: compressed air leaks, reduced air pressure, and the use of engineered nozzles. Repair of compressed air leaks is a very easy fix to accomplish. Everybody kind of knows it. One thing is that the DOE found through a large study that typically, if there is no planned maintenance on a compressed air system, the leakage volume will amount to like 20 to 30% of the air compressor capacity. If you have a 100 horsepower air compressor, that'll produce around 400 CFM. And that means that about 80 CFM is lost to leaks. If you go through the calculations for a single shift operation and 5 cents per kilowatt hour energy price, that equates to about $1,600 a year. If you go to 24/7, 365 operation, that is about $7,000 a year for fixing air leaks. That's extremely common. We recently went to a place that is doing a lot of welding, and their compressed air lines were fairly close to their welding gas lines. And we found argon and CO2 leaks with our ultrasonic analyzer. And so you kind of have to watch that a little bit too. Reduce compressed air pressure. If you're raising the pressure over and above what it is required to do for your process, you're going to end up using a good amount of power extra to accomplish that. The rule of thumb is that for every 2 psi higher pressure that you need, that you pressure things up at above what you need, you use about 1% higher use on the air compressor. You go through the same air compressor and say your PSI was about 20 PSI, which is not adverse to what we often find, that's about 10% more air compressor power use. And you see the numbers there for a single shift operation and for a 24/7 operation. So it tends to amount to a couple $1,000s on that also. We went to a place, the same place that had the sales tax problem, and they had about a 20 PSI overpressure going on a total of about 1,600 horsepower. And it amounted to about $20,000 a year on their cost for that. The last thing I want to cover is the use of engineered nozzles. Anything that you're using compressed air to blow off, product movement, cleaning, drying, anything like that that use compressed air is basically an organized air leak program where you're setting up an air leak. They have what are called engineered nozzles that will entrain the ambient air into the flow stream that's generated by the compressed air and reduce your compressed air usage quite a bit, by about 80% or so. And thereby a 30 CFM nozzle before comes about 6 CFM usage afterwards. And the cost drops, well, from $600 a year to about $120 per year for that nozzle. And if you have a bunch of them, that tends to add up fairly quickly. So we see quite a bit of that too. That is the whole of my presentation. We do come to manufacturing plants all over the state within about 180 miles or so and do these no-cost assessments. We will entertain the idea of coming to your plant. We are currently looking for plants for our summertime schedule. So it's a good program, good for the students and good for y'all's company. Thank you, Alan.
Very good. Thanks, Jim. So
Yeah.
you mentioned these sales tax exemptions.
Yes.
So how commonly do you find that is an issue on the sites? Because it sounds like the sort of thing that people who are in the plants, the buyers, the people who look after the invoices should be aware of this.
Well, somewhat they are, but what I really wanted to highlight is the fact that, a couple of plants that we went to had fairly sizable sales tax problems, but in the past they fixed them by doing the predominant use study and turning the certificate. But the time when they changed power companies, whoever was watching that process didn't turn the certificate over.
Okay.
And again, the place we went to in Northeast Texas was basically about 6 weeks ago. So it's not an old occurrence. It's something that's continuing.
So what sort of percentage of sites you visit would have this problem? Any feel for that?
I'd have to guess somewhere north of 25% of the places we go to.
And this is on both electricity and natural gas?
Yes, at least in Texas it is anyway, yeah.
Okay. Or is it any kind of fuel or specifically natural gas?
Well, specifically electricity and natural gas is what's mentioned in the Texas Administrative Code.
Okay.
Yeah.
Okay, now I'm going to give you the hard question, right?
Okay, okay.
You mentioned power factor correction. So
yes,
could you give us the 2-minute summary of what power factor is and why it's an issue?
That is a hard one.
Yeah.
Anytime when you've got electrical power going into an inductive load, it generates a magnetic field. And when that magnetic field gets generated, it takes power to do so. And the power factor takes into what I'm a mechanical engineer, and we've got a term for this. It's called imaginary power. It's the reactive power that goes into the windings that energize the magnetics and makes a motor run. It doesn't actually do work for you, but it goes into energizing that magnetic field. That's also in lighting ballast, like a fluorescent lighting ballast and places like that. Anytime you got an inductive load and you got some power going into it, it's energizing a magnetic field. And that's the percentage of the power basically that goes into that magnetic field.
Okay, great.
Yeah.
Good.
That's a short explanation off the fly here.
No, that's good. That's good. Yeah, it's certainly something that causes a lot of confusion, certainly to a chemical engineer like me.
Yeah.
There's some electrical engineers on the call who could give something more detail, but that sounded like a pretty good explanation. Probably one of the most straightforward explanations I've heard. So good job. Great. All right. So I think thanks. I think we're pretty much right on time. So let's move over to our final speaker. Thanks again, Jim. Much appreciated.
Sure. Appreciate it.
Now I'd like to welcome to the podium Dub Taylor with PACE, the Texas Pace Authority, and Dub, over to you.
Thanks, Alan. You can go ahead and move to the next slide, please. My bio, I think Alan is linking to, or it's coming up in the chat line now. I won't go through this other than to say that I've spent about the last 25 years focused on clean energy technology deployment and financing related activities, mostly on the public sector side, but also a handful of industrial energy efficiency support programs, including the one that is now supporting this activity today. So been very plugged into industrial efficiency for quite some time. Next slide, please. So our organization, the Texas PACE Authority, we are a nonprofit, and we work for local governments around the state to administer PACE programs. I'm going to get into that in just a moment. We work with property owners, service providers, and capital providers to help facilitate deals and transactions, but we don't provide funding. We don't do the work, the service itself, and we obviously are not the property owners. So we sort of work in the middle. We're the conduit to help with these transactions. Next slide. So what is PACE? You may have heard this acronym, and what it stands for is Property Assessed Clean Energy. And then it's really a financing structure. So the F is missing, but when you hear of PACE in the energy context, this is what it means. And it's a simple way of paying for projects that have high capital costs and long-term benefits up front in a means that is cash flow positive from day one. In the state of Texas, this financing mechanism is available for industrial and manufacturing properties, as well as multifamily, commercial, and other types of non-residential. The types of projects that can be financed save energy, water related demand, or provide distributed generation on the customer side of the meter. And the key to this all is these loans are secured through an assessment on the property that provides security for the lender so that they can extend the financing terms for much longer than they normally would for a typical equipment loan, which allows the projects to cash flow right away. Authorized under state law and implemented and authorized at the local level, and then it's voluntary and open market, so not a requirement, not a regulation. It's simply a tool in the tool chest to help facilitate project implementation. Next slide, please. So in Texas, as I mentioned, it is a local option program. So to date, 56 local governments have enabled PACE, covering about 60% of the population. Cities and counties, a mix, with more sort of adding to this list each day. Next slide. And why are they doing this? Well, it allows owners within those jurisdictions to improve the condition of the assets in a cash flow positive and budget neutral way. Lowers the utility and operating costs from the owners and increases net operating income. In the two graphs here, and I think this is important to spend a little bit of time on the difference. In a conventional financing scenario for equipment replacements, normally the term for financing is not a very long time. It could be 5 or 6 years, but these are considered unsecured loans, so the lender wants to be repaid as soon as possible. If the project goes into default, the likelihood of them repossessing or removing the equipment is low, and so there's higher risk. They'd like to get that paid back quickly. So as you can see on the left, the repayment is much higher than the utility savings for the first phase of that project's useful life. With PACE, the difference there is you really extend that repayment over the useful life of the project, so it better aligns with the benefits created by these longer life projects. It also increases, obviously, net operating income, so it can be cash flow positive day one. So that's really the key difference. It's a longer term financing for projects that have longer life and longer benefits. Next slide. So to date in Texas, the PACE market is growing. As you can see the bar at the left, transactions and the dollar volume have increased each year since PACE started. About half of the projects that have been financed are energy efficiency, about a third water related, and about 12% distributed generation. And one thing we've noticed is that the industrial, you can see where the arrow is there, has been really kind of the smallest segment overall. And so we dug into that last fall to try to better understand from a plant manager's perspective, why this was happening. So next slide. And some of the misconceptions that we uncovered are these here. One of them was that, this is for commercial properties only, not industrial. Well, in Texas, it is for industrial. So a large plant, manufacturing plant, equally eligible as a building. Also, that this is limited to really smaller projects, HVAC and lighting. Well, no, it can be used for very large projects, large industrial retrofits, microgrids, combined heating and power. Also, a concern that, well, okay, this pays for the equipment, but there are soft costs, there are engineering, there's other associated costs, commissioning. What about those? Those costs can be rolled into the financing as well. Another thing we heard is, well, since this is government enabled, it uses government funds and there are strings attached and reporting and things that, you know, create challenges for us. That's not the case. It is actually private financing that uses this governmental conduit mechanism. So there is not reporting and that sort of thing that you would expect with a grant or governmental funding. Another thing we heard is that, well, we have a project that's $100 million and that's way beyond what PACE can finance. There's really no upper limit on what can be financed through PACE. It's really the tolerance of the individual capital providers. If you have a strong balance sheet, if you are a high credit rating institution or company, then probably the type of project you have in mind could be financed. Another thing we heard is it can't be mixed with funding sources. Well, it can be. It can pay for 100% or it can pay for a portion of an overall project. Another thing we heard that you have to use a specific set of contractors or capital providers. No, that's open as well. So if you have a preferred contractor or financing entity, those can be pulled in and used through the PACE mechanism. And then finally, the thing we heard as well, I think there's a deadline, right? And we may have missed it. And it doesn't really sync up well with turnarounds or shutdowns at our plants. And that's not the case either. It actually can be used when you need it, really on your schedule. So some misconceptions, which hopefully we can continue to work to clarify in the industrial space. So looking at industrial energy consumption, it's a big opportunity, 25 quads overall. The numbers have been pretty consistent. And most of that is chemical manufacturing and refining, which is what we have in Texas. So big opportunity that's untapped still. Next slide. The other thing that is probably more high on a corporate awareness level is ESG, environmental, social, and governance issues. And the risk profile for chemical manufacturing and refining is very high. This is an issue that obviously is being addressed through environmental projects, but energy projects and water savings projects have environmental benefits that can be quantified and can map toward ESG goals as well. So that's, I think, a new driver. Next slide. A challenge we have in Texas, and this was highlighted earlier, is if you're trying to justify a project on savings, we have very low electric costs, very low energy costs generally compared to some other market areas. So that's presented a barrier and prevented some investments of internal capital on these types of projects. Next slide. Go ahead and move to the next one. Okay, are we frozen up?
I'm with you, Doug.
Okay. Okay.
Yeah. Looks like the slides are stuck though, maybe. I don't know.
Slides are stuck. Okay.
Yeah.
Let's see. I was going to see if I could control it.
Yeah, I was trying as well. Lee, you're not able to control it? I can maybe pick it up from my computer. So
I am moving it forward. What slide are we supposed to be on?
Let's see. Looking for slide 12.
yeah, it's 12 in your part of the deck. See if I can share it from here. Okay, are you able to do it, Lee?
Yeah, hold on, I'm trying.
If not, I'll take it up from here.
Okay, do you see it now?
No.
That's weird because I'm advancing on mine.
Okay, I will try to do it from mine.
Financial impact of PACE, that's where I'm at.
That's
Yeah.
what we're looking for, right?
We're not seeing it though. Do you see my screen?
Yeah, I see it
I can
now.
see that.
Okay, let's. Okay, let's see if we can go from here.
Okay, you want to go to the next one?
I will try. Okay, there you go. Okay.
All right. Okay, here we go. The slide we've been waiting on. Yes. So the financial impact of PACE, and I would say that at the bottom of the slide here, we actually have this calculator. It's a tool on our website where you can do these comparisons for yourself. But a challenge in moving these capital intensive projects forward, obviously, is first cost. And if you're investing your own capital, typically you're going to have a payback tolerance of a fairly short time, 2-3 years. Maybe 4 if there's co-benefits, ESG related benefits, other things. So the graph here shows you the yellow line. This is $1 million project and where the payback occurs. So you go negative, obviously, because that's dipping into your own operating capital, your capital budgets. And then you're cash flow positive about year 8, which may be well outside of the tolerance of what your corporate investment, your capital committees may like. Which is why these projects have not been done. The orange line shows a typical borrowing scenario where it's maybe 20% down for an equipment upgrade. And again, there you're cash flow positive about year 9, well outside the window that most people are looking for. In the PACE scenario, which is the blue line, it's actually cash flow positive day 1, just the way that it's structured over a longer term. So this can address a lot of those concerns that are preventing investment of internal capital and preventing some of these projects from moving ahead. So next slide, please. There we go. So the types of things we're talking about, again, any type of a project that reduces energy or water usage or demand or generates energy on site potentially is eligible. And in the industrial space, these are just examples of those types of projects on the energy side, everything from equipment to mechanical insulation to compressed air systems, you name it. On the water side, reclaimed water use, RO reject, water management systems. And then on site, Gavin started us off with CHP. CHP systems can be financed through PACE, as well as renewables and other types of technologies. Next slide. There we go. And on the soft cost issue, any costs related to installation of the equipment can also be rolled into the financing. So it's not just equipment, permitting fees, engineering, design, commissioning costs. And then on the financing side, there's going to be lender fees and such. Those can also all be rolled into it. Next. And the process kind of works like this. You, the owner, would identify a contractor to work with you to do an energy and water analysis of your project. That would be reviewed by an independent third-party reviewer, a Texas PE. The project would move into construction. There would be an installation verification, and the owner selects both the contractor and the independent third-party reviewer, but that third-party reviewer is there to provide confidence that the savings that are projected will actually materialize, and that will offset the financing costs. So next slide. All of this follows a set of common standards. Again, PACE was enabled through state law. So there is a law in the books that sets out the parameters of how PACE can be operated. There's then a more detailed set of guidance called PACE in a Box that's been used uniformly statewide. And then our organization, we've got detailed guidelines. So this all is a common set of published standards that are followed for these projects. And next slide. So in summary, we believe PACE is a win-win-win, actually 2 more wins. So it's a 5-win. Property owners benefit from lower energy bills, greater resilience, property value increases. For contractors, oftentimes if you're working with a customer, you're developing a scope of work that always gets VE down because of budget constraints. This is a means of allowing you to keep that project integrated so that it is operating and gets installed in an optimal fashion, performs well for the customer. For lenders, this is a highly secured loan if they want to provide this type of financing. For the state itself, kind of the public benefits that accrue from this are reduced peak power demand and increased grid stability, air quality improvements, water resource conservation. And then at the community level, this allows plants to be more competitive. As we've seen in pricing events, say post-hurricanes, where you have operations with multiple sites around the world, you're going to go to the lowest cost operating site. And if that's not in Texas, that means the community loses because those jobs either are temporarily gone or gone permanently. And this allows those plants to be more competitive and remain in place longer. Next slide. That's it. Happy to take questions. Here's my contact information, and everything I've talked about today is covered in more detail on our website. And I will also say that we have a webinar a month from now that's going to be just on PACE for industrial, which will be a full hour kind of diving into the details of a lot of these things. So hope you'll join us then. And Alan, I will stop there and see what questions have come up.
Sure, thanks, Dub. So we made it through, as somebody said here, a dramatic pause in the middle there, but that worked out quite well. So thanks for staying with us, everyone. There are a few questions here in the chat, so I'll toss them your way and you can bat them out of the park here. So the first one, first two are probably fairly quick ones. Are residential single-family projects eligible to participate?
No, that's an easy answer. Under state law in Texas, that's actually the only category that's not allowable. So a residential 5 units and greater, and then any commercial and industrial property is eligible.
Okay, so you have to be up to 5 units to qualify.
5 units, right.
Yeah. Then the next one, I think you may have sort of touched on this in your talk, but can PACE be utilized for microgrid development? You talked about distributed energy. Is that basically the same thing?
It can be. The key would be the microgrid system would need to technically be on the customer side of the meter or point of interconnection into the grid. So if you had multiple facilities with a single point of interconnection and a microgrid behind that, yes, that's something that could be financed.
Okay, and actually just picking up on that first question, another angle on this, can condo buildings qualify with many owners in one building?
Condominiums and individual ownership, it provides, it's a trickier arrangement. I think contractually, you could have common improvements done to shared facilities. Individually, though, there may be some limitations. We haven't seen a lot of condo projects, so it may not be the best fit. Apartments certainly are a good fit. Condos, we'd probably have to look at it case by case.
Okay. Next question, can PACE be used for solar?
Absolutely. We actually just, the last month, we did a webinar in conjunction with the Texas Solar Energy Society on just that. Solar is a distributed energy technology like CHP, obviously a different technology, but if it's on the customer side of the meter and it's reducing demand or providing power, part of your power or all of your power, then that certainly is something that could qualify. And solar projects, electric rates in Texas are pretty low. So, a 15 to 20 year payback on solar projects is not unusual, depending on where you are. And that's usually beyond a lot of financing alternatives,
sure.
But not for PACE. So it could be a very good match.
One more question here, and I don't know whether you have the information on this, but he does ask the question, do you have information, this is from Stephen, do you have information on why industry has such a low participation rate in PACE?
Well, I think a lot of it is, again, when I sort of went through the common misconceptions, when we talked to industrial plant managers that had even heard of PACE, I think they had heard of it really just in the commercial building context. I think there's a lot of education and awareness. I think the other is that historically, companies are looking to invest their own capital in these sorts of projects and have not really looked to external financing. There may be a shift because a project financed through PACE could be done today rather than sort of kicking it down the road for years. So it's probably a different mindset at the investment level, but also PACE is still fairly new, and we haven't done as good a job as we can helping educate and communicate the benefits.
Okay, fair enough, good. One more follow-up question, which sort of merges two of the earlier ones together. Can PACE be used for community solar projects?
Yeah, community solar, it can be tricky. It depends on where the assets are located. Potentially, it could be financed, and there could be contractual arrangements to meet all the qualifying criteria. Again, that's kind of a case by case, not a standard scenario, but not no, but maybe. We just have to look at the details.
Sure. Okay, fair enough. Good. All right, I think those are all the questions here in the chat. So I guess, and we're kind of right on our closing time for this. So thanks to you, Dub, for that great talk, and you're dealing with the Q&A. And thanks to everyone for your talks and also for the logistics. We actually managed to keep this pretty much on time, which is a good job. I know we had a lot of material to get through. There are just one or two more slides if the gremlins will let me move forward. First of all, this one here, I know many of you were interested in the PDHs, and if all is well, the system should now be open, and you can claim your PDH certificate. And Kyle has very kindly put the link in the chat for us as well. So go ahead and you can now claim your PDH certificates. And then also just a sort of program update for the Texas Industrial Energy Efficiency Program. Our next major event is coming up on May 6th, which is, I believe, just 3 weeks away. It's also a Thursday, 4:20 to 5:50 p.m. And that will be our water forum, which is about reducing water use in manufacturing plants. And you can find more information about that and all of our events on the website, and the link is on the screen, and you should also find that in the chat too. Let's see. And I guess that's pretty much all I have here, unless anyone else has anything to add.
Alan, thank you.
Thank you, Jim. Glad you could join us.
Yeah.
Thank you for organizing. Yes.
Thank you.
It's been fun. Yeah. All right. Well, thanks so much, everyone. I guess we're giving you about 2 minutes back to your day that you weren't counting on. But thanks all for joining us, and we look forward to seeing you at the next TEEP event.
Sounds good.
Thanks, Alan.
Thank you, everyone.